Hi everyone, let's study exponents today. So, suppose I would write 2 into 2 into 2 into 2. It would be 2 to the power 4 because 1, 2, 3, 4. 4 times 2 is multiplied. And if I have x into x into x, 3 times it is multiplied, I would write it as h to the power 3 or x cube. Suppose a gets multiplied with itself 5 times. 5 times a gets multiplied, I would write it as a to the power 5. It is the exponential form of numbers. In this way we write the power. When something gets multiplied with itself any number of times, then that would be written in this way. 5 times, so a to the power 5. 7 times, so a to the power 7. How many times? To the power, the number to the power that much. So suppose it is a to the power n. In this case, this is n is called the exponent or power, exponent or power, and this a is called the base. So there are certain laws that we need to know. We must learn those laws so that we can follow them while solving problems. It would be necessary for us to know the laws. So let's start the laws of exponents. So first law is like this. Suppose a to the power m gets multiplied with a to the power n. See, here multiplication is done and both the bases, in both the cases bases are the same and powers are different, and here we do multiplication. Formula applied would be, we would keep the base same and add the powers simply. So what are the powers? M and n. Remember that m and n are integers. The powers are integers. We are studying in this chapter, they are integers only. So m and n. In other classes, we would deal with powers being rational, any other number, fractions they can be, decimals means anything they can be. But here in this chapter for class 8 ICSE, we are studying integral powers. So this is a to the power m into a to the power n is equal to a to the power m plus n. Here m and n are integers. Now take an example, you would understand it better. Suppose 2 to the power 5 gets multiplied with 2 to the power 3. Here bases, you can notice the bases are same, powers are different. What are the powers? 5 and 3. So we would keep the, as per the rule, as per the law, we can keep the base same and simply add the powers. We can simply add the powers. Here we have 2 to the power 8. This way we will apply the first law. Second law, the second law goes like this. Second law is, suppose we have a to the power m divided by a to the power n, where m is greater than n. In that case, we would have a to the power m minus n. This is the case when we subtract n from m, when this m is greater than n. So you must remember this is applicable when m is greater than n. And example we would take, suppose 2 to the power 10 is divided by 2 to the power 7. Here 10 is greater than 7. That's why the answer would be 2 to the power 10 minus 7 equals 2 to the power 3. But suppose we have a to the power n divided by a to the power n in such a way that n is greater than m. In that case, our answer wouldn't be a to the power m minus n. In that case, answer would be a to the power 1 by a to the power n minus m. So take one example. Suppose 2 to the power 13 divided by 2 to the power 15. Here you see 15 is greater than 13. So answer would be written like this: 1 by 2 to the power 15 minus 13. Here we have 2 to the power 15. This power is greater than this power. That's why 1 by 2 to the power 15 minus 13. It would be 1 by 2 to the power 2. So So this way the answer would be. Further we would write it as 2 to the power minus 2. We would learn that in another law. But for the time being you understood that when m is greater than n, this power is greater than this power, that time a to the power m divided by a to the power n would be a to the power m minus n. But when we have n greater than m, in that case a to the power m divided by a to the power n would be 1 by n a to the power n minus n. It is the case when n is greater than m. Means in the denominator the base has a greater power than the power of the base in the numerator. So this power n is greater than m. That's why a to the power m divided by a to the power n gives rise to 1 by a to the power n minus m. N minus m is done in the denominator. Now come to the third law. The third law goes like this. Suppose a base is there which has two powers. Suppose the base is a and its power is m, further whole to the power n. Like this something is given. So you see a is the base, it has one power, further it has another power n. In that case the law applied is a to the power m into n, means a to the power mn. Take an example. Suppose 5 to the power 3 whole to the power 2. So here one power is 3, another power is 2. We shall apply 5. We will keep this base. Then to the power 3 into 2. To the power 5 to the power 3 into 2. That's equal to 5 to the power 6. 5 to the power 6. And suppose we have a to the power m. Another law is there. It is the third law. Fourth one is, suppose a into b, two numbers, different numbers are there and they are having one power. Suppose that is m. A into b whole to the power m. We can split this into a to the power m multiplied by b to the power m. B to the power m. Take one example. Suppose 2 into 5 whole to the power 3. We have 2 into 5. 2 is a different number, 5 is a different number. They are multiplied and their power is 3. Common power is 3. We can split it as 2 to the power 3 multiplied by 5 to the power 3. We can split them like this. Now, for fifth one, the fifth law is, suppose a by b whole to the power m is given. You can take it like this, a to the power m divided by b to the power m. Take one example for this. Suppose 10 by 7 to the power 5. You can write it as 10 to the power 5 divided by 7 to the power 5. This way quotient of this can be obtained. So this is another law. This is after this one thing we will get to know that if a number is negative, suppose minus a to the power m is given. Just imagine this m is the power of a base which is a negative number. This is a negative number. This is number 6, law number 6. Minus a to the power n. When m is even, the answer would be something different. When m is odd, the power is even, and when the power is odd, that time the answers would be different. So when this is a negative number, its power is suppose even. In that case, answer would be even, means it would be positive. If the power is even, then the answer would be positive. It may be a negative number, but even number of times when a negative number gets multiplied, it would give rise to a positive answer. That's why the answer would be equal to a to the power n. Take one example. Suppose minus 2 is there. Its power 2. 2 is an even number. The power is even. So we will multiply it how many times? 2 times. And as we know, when a negative number gets multiplied 2 times or even number of times, it gives rise to a positive result. That means it gives us 4. 4 is nothing, it is equal to 2 to the power 2. Here we had minus 2 to the power 2. It is a negative number, its power is even. That's why the answer becomes numerically the same. 2 to the power 2 it becomes, but it becomes positive, not negative. Although the base is a negative number, we don't have negative answer. On the contrary, when we see a to the power m minus a to the power m is a number when m is odd, in that case it would give rise to negative answer. So the result would be negative, and how much it would be? Numerically, a to the power m is how much? That much it would be. For example, 2 to the power 3. 3 is an even number, minus 2 to the power 3. So minus 2 will get multiplied 3 times. Minus 2, minus 2, minus 2. 3 times. Minus 2 into minus 2, it would be plus 4. Again plus 4 into minus 2, that would be minus 8. That's why minus answer would be negative, and numerically 2 to the power 3 will be how much? How much it would be? 8. So 2 to the power 3, simply with a minus sign we would write the answer, because 2 to the power 3, it is minus 2 to the power 3. 3 is an odd number. That's why the answer would be negative, and we would put a negative sign outside this 2 to the power 3. Means 2 to the power 3, that's 8, minus 8 would be the answer. Next, seventh law says that if any number is there, any number, its power 0 is given, it would always be equal to 1. But keep one thing in mind, that a is not equal to 0. The base is not equal to 0. So take minus 2 to the power 0, it would be 1. 7 to the power 0, it would be 1. 5 to the power 0, it is also equal to 1. So this is the seventh law of exponents. Now eighth law, we will see that suppose there is one number written as 1 by a to the power minus m. Suppose there is a to the power minus m. So the negative power of a base is given. It can be written as 1 by a to the power plus m. It is a to the power minus m. It can be written as 1 by a to the power minus m. Plus m. And suppose 1 by a to the power minus m is there. You can write simply it as a is having minus power in the denominator. We can write it as a to the power plus m. For example, 1 by 3 to the power minus 2. It will be written as 3 to the power plus 2. Why? Because in the denominator, the base has a negative power. In the numerator, this same base will have positive power. And take this one, a to the power minus m is equal to 1 by a to the power m. For that one example we can take. Suppose we have 6 to the power minus 7. 6 to the power minus 7. It can be written as 1 by 6 to the power plus 7. 1 by 6 to the power plus 7. See, in the numerator 6 has power minus 7. But in the denominator it will have plus power, positive power. So this is all about your exponents and the laws of exponents. And in the next class we shall solve the questions of exponents of exercise 2A.